In this video, I'm going to go over the solutions for the remote day 3 assignment for AP Physics 1. All right, cool. So let's see. Oh, we're getting into the rotational stuff now. Let's go. So first things first, we need to, there aren't any like terms between these two expressions here. So I need to move this over before we start dividing. So this character is called omega, and since it is added, I'm going to subtract it. So omega naught, or omega 0, if you want to call it that. A lot of students don't like the sub naught thing for whatever reason. Okay, minus equals alpha t. We're going to learn some of the Greek alphabet while we're doing all this fun. And then we're going to divide both sides by t. And that is enough to isolate alpha. All right. Cool. So another easy one, divide both sides by r. And that will get us omega. And that's enough. You know what? I'll try to keep the color scheme. Oh no. Okay. All right. Oh yeah, this one looks really familiar. You know why? Because it's the rotational form of the equation that we saw. Don't do that. Sorry, the cat's scratching on the floor in here on the carpet. I'm like, no, don't do that. Yeah, it's just like this equation except for rotation. So it's got all the same variables and stuff in it, just referring to rotational motion. Anyways, back to this. So the processes are going to be identical. We're not doing anything different. It's just weird looking variables. We got a theta, we got an alpha, we got a t, and not like terms. So I'm going to go ahead and move this theta 0 over to the other side. Now, something fun we could do here, if I wanted to really torture you as a physics student, is I could change this to delta theta, because all this is saying is beginning theta and end theta, so it's final minus initial. So I could replace that with a delta theta if I really wanted to. But I'm not going to do that to you. Now that equals 1/2 a, no, it's not an a, alpha t. I'm not good at writing alphas squared. Okay. And we're going to now divide both sides by 1/2 alpha. Okay. And that is going to give us theta minus theta 0 over, I'm going to go move the 2 up here from the 1/2 divided by alpha. Remember, dividing by 1/2 is the same as multiplying by 2. Okay, and that equals t squared. And then to counteract, to undo the squared, we're going to take the square root to isolate t. And there you have it. That's square root of 2 theta minus theta 0 over alpha. That is your solution for that one. That was a lot more work than the next one. Next one, we're just going to divide both sides by alpha. It's poorly written as my alphas are. That will give us r equals a t. Talk about what that t means later, over alpha. Maybe that's a better alpha. Maybe that's the best one yet. How about that? I think that's the best one. All right, now, oh no, here's another fun one. That looks really familiar too, doesn't it? Let's go on a little trip here. I bet. Yeah, it looks just like this. So it's going to be a very similar process to the other one. Yep, not like terms. I'm going to go ahead and move the omega 0 squared over to the other side by subtracting it. Oh, about to mess up my color scheme. So minus omega 0 squared minus omega 0 squared. Omega squared minus omega 0 squared equals 2 alpha theta minus theta 0. Yes, and we're solving for alpha, so we need to divide both sides by 2 theta minus theta 0. And is the party over? I think the party's over. That's really it. You could put those in parentheses if you wanted to. 2 theta minus theta here. And remember, you cannot just say like omega minus omega 0 and then put the square out here. Like that doesn't work, because then when you box or FOIL that term out, you don't get exactly this back. You get something different. So this is all we can do to it. And I almost forgot that, and that all equals alpha. Okay, so there you go. And yeah, so scribble that out. Oh no, we're solving for theta and it's in a trig function. Whatever will we do? We're going to do algebra. So first things first, we can't move the sign, but we can move the R and the F. So let's do that. R, F. Okay, so what we have here is we have torque, tau, divided by RF equals sine theta. And what you should remember from algebra is that when you have a trig function, the algebraic way to remove that trig function is to take the inverse trig function of whatever that is. So we're going to do inverse sine of both sides. And that is going to give us theta equals, because it'll remove the sine, inverse sine of tau, torque, divided by RF. There you go. That's one you probably don't use very often, so it's understandable if that one you're not super comfortable with for whatever reason, or it's not fresh in your mind. All right, on to the back. The parallel axis theorem. Sounds hard, it really isn't. Not like terms, so we're going to move the not like term over to the other side, so we can solve for the d. So we're going to subtract Cm. Learn what those things are later. Minus Cm. So I prime, that's how you say the little dash thing there, I prime minus Cm equals md squared. And then we need to solve for the d, so we're going to divide both sides by m. And I see in our future taking a square root. I prime minus I cm over m equals d squared. And so we're going to square root both sides, and I'm out of room, so that is where I'm going to stop. All right. Wow, that looks like the kinetic energy formula. And in fact, it is. It's the rotational kinetic energy formula. So it's got the omega for how fast it's spinning versus a v for how fast it's going. It has I for the moment or the rotational inertia versus that would be an m if it was regular kinetic energy. Okay, so anyways, we need to divide both sides by 1/2 I. And then we're going to take a square root. Like, dividing by 1/2 is the same as multiplying by 2. Multiply by the reciprocal when you divide by a fraction. And that equals omega squared. So we're going to square root both sides. And that, I guess I have room to write it. Omega equals square root of 2k over I. Cool. That wasn't too bad. Alright, make that go away. Okay, more fun stuff here, solving for a variable in the denominator. I'm going to go ahead and scribble out the subscripts here because we really don't need those to differentiate the variables, so it's going to make our lives easier. Remember what I told you previously about multiply by, or go ahead and get the variable out of the denominator, because it is less likely that you will make errors if you get the variable out of the unknown variable out of the denominator. So I'm going to do that first. So that gives me torque tau equals I alpha. And my goal is still to solve for I, so I need to divide both sides by alpha. And that will give me a solution. I equals torque divided by alpha. Cool. Wow, this video took a long time. Oh well. All right, last one. This one will not take a long time. Just divide both sides by tau, and you're good to go. So delta theta equals W divided by tau. Okay, so we can do algebra even if we don't have a clue what the variables stand for in physics world. Thanks for hanging with me to the end here. Feel free to ask if you have any questions, and have a great day.